because currently it sits there in space where it's not I want it. And rotate it and then just move it down. Luckily, I have written down all the dimensions, which makes it a bit easier. Okay, so there. Okay, and then the feed chute automatically has an inlet that you can use for the particles. But I also want to add the inlet for the water. So what I'm going to do is I'm going to add a rectangle over here, which I'll use for the SPH particles. Okay. Again, on geometries, I'm going to say create a rectangular surface. And I'm just going to call it inlet water. Okay, and then again, I just wrote down the dimensions. So it's easier to quickly type in. Okay, so that rectangle I will then use as my inlet. Okay. So for those that want to know about the outlets, if I had an outlet, which I have, but the particles will not go out now. You can also create a rectangle or a sphere or import a surface and then make use of that surface as an outlet boundary. Okay. So basically you also just create a surface. Remember, not a wall. So you'll see Rocky has changed a little bit for those that has been using it. So it's not a wall, it will be a surface. So surface is a face where particles can flow through. Okay, a wall obviously will the particles will not go through the wall. Okay, so there's my geometry. But the next step is just to look at my materials. I'm happy with the default material, so I'm not going to change anything on the material properties. You can see there's my typical material properties for particles, and then for the SPH particles, I have fluid materials. So the default is water, which I'm happy with, but you can, if you're solving for a slurry, for example, you can change for density or viscosity. Also, the sound of speed can be changed here. Now, the sound of speed is typically reduced artificially because the sound of speed affects the time step that these SPH particles can take. So if you actually put the real sound speed on, your simulation will be quite slow. So you can reduce the sound speed quite significantly without losing a lot of accuracy in your simulation. Okay, so that's why you'll see the default sound speed is set to 100 meters per second. So this is similar to reducing the Young's modulus of the particle material. So it's the same type of idea with the SPH particles. Okay. So next is to actually create my particles for my DEM simulation. So I'm going to create a new particle. The first one will be larger particles with polyhedron. Just change the shape. Let's view it quickly so we can see what it looks like. So I'll make that 1.7, 1.55, and then just 13 angles, and then 2.5. Okay. So there's my larger spherical, larger polyhedron particles. I need to put a size distribution, so I'm going to have two sizes, 0.2 and then 0.15 and sorry, 0.15. The numbers 30%. And then I also have spherical particles. 0.1 for the larger size and then 0.05 and 50% of them. So that's the size. Then on the SPH side, here I can set some interactions. So turbulence will be LAS in this case, not laminar. Viscosity type, I'll use the Cleary model. That's fine. You can see here is this kernel size. The kernel size effect. That's how basically you set the size of the SPH particles. As we know, it should be smaller than our DEM particles. For this specific case, I'm not going to make it too small, otherwise we won't solve it. But basically, I'm going to just use 20 millimeters at this stage. Okay, so it's slightly bigger, so about 2.5 times smaller than the small sphere that I have. but for the demo, I think that should be sufficient. Okay, then my inlets and outlets. Create a particle inlet. Okay, the particle inlet, as I mentioned, will be at the feed conveyor. I need to specify inlet, so I have large and small particles. The large particles will be 300 tons per hour, small particles 700 tons per hour. And then I also need the inlet for the SPH, so I'll create a fluid inlet. The fluid inlet will be on that inlet water that I've generated. And then the most flow rate for the fluid will be 500 tons per hour. Okay, then I'm fairly happy with what I have at this stage. I can go to my solver, and then I want to solve from the GPU, not the CPU. Okay. Now my laptop's GPU is a little bit old, so I'm not going to do it at this stage. What I'll rather do is, well, I guess I can maybe just start it. And then it will generate the initial conditions and so forth, then start the solver. Okay, that's not bad. So while that happens in the background, do like the cooking channel, and then open my solved model. Okay. Okay, so this is now the solved model that I have. I just the particles will switch on. So I've solved 20 seconds of this just so you can see what happens. So if you just look at the particles first, I colored it now by translational velocity, which you can select over here at the top. This makes it easier to see what's going on. What we can see is our small spherical particles, as well as then our larger polyhedron particles. And then they flow through the domain. And what you'll notice, it is slightly biased. Sorry, it's a bit slow. You'll see the particles are a bit biased towards the one side when it flows through the chute due to this flow direction that we have over here. And what we see if we plot the SPH particles and switch that on, is that you can actually see how the DEM particles block the flow of the water through the chute at this stage. Okay. So a lot of flow rather goes to that side because of the blockage caused by the DEM particles. The other thing that you'll see if we look at on this side is that normally DEM particles should fall into a heap over here. Create a heap of particles, but as you can see, as the SPH particles flows, the DEM particles will also flow with it, and that's why we get that the DEM particles also flows to the end of the model that we have. Okay. So you can see I just colored the SPH particles with a different color. That changes. You can change these. So I can maybe, for example, make that also 7 meters per second. I can change the coloring there as well. I can maybe change that with dark blue, light blue, for example. Show that. And then the other thing is obviously these SPH particles is not really representative of the total mass of the system. So what sometimes needs to happen is you need to create an Euler solution from the SPH particles if you want to look at the mass, for example, of the fluid. Okay. So for that, you'll see I have an Euler solution. The Euler solution basically creates a structured grid over your entire domain. And basically that then interacts with the SPH particles to extract mass information, for example. There's a lot of elements obviously in this mesh, so it does take a little bit of time to actually plot, but there you can see there is my Eulerian mesh that's been generated in the background, and this mesh is based on that SPH size that I've specified. So each of these elements is 20 millimeters square. So I'm not going to display that, but what I want to show you now is from this Euler mesh that I have, I can create a property of weight, and then basically extract all the Eulerian cells where the weight of the cell is between specific ranges. So let's start with the weight is between, say, 0.1 kilograms and 1 kilogram. It does take some time because it needs to extract all those elements. Okay, but if I switch off my SPH particles now, you can see that those elements have been selected. And then those elements, then I can add transparency to it. I can change again the coloring. I can switch off my edges. So it starts to look a little bit more like water at this stage. But obviously the SPH elements are still quite big, so that is very blocky. Okay, but with this now you can again actually extract the weight of the water inside the domain. Now that takes a bit of time to generate, so I've pre-generated that. But you'll see you can right click on the weight and then create a time plot and show that in a new time plot. And then obviously at this stage that's just linear, but you can see obviously the weight of the water is increasing as the simulation progresses. Okay. Yeah, I think that's the main things that I wanted to show you. See, my simulation is my computer is quite slow, my laptop, because the GPU is quite old. But what I can show you, for example, is on the solver over here. I can show you simulation time in a curve. Okay, so here you can see how much time it takes to do 20 seconds. So 20 seconds of the simulation took about 5 hours to solve. So if you had to do this with the CFD-DEM coupling, definitely 5 hours will not be enough to solve 20 seconds. It will take maybe 4 or 5 days on the same hardware that I had to solve this, because this was just a single i9 desktop with the GPU, not even a Titan GPU. This is just a GeForce RTX GPU that's been used. So fairly standard, basically a gaming graphics card that's been used. So it's not the most expensive one available, and it did solve quite quickly for this. Okay. So yes, that is basically it. Any questions?
Thanks for that, Stefan. I think it was very thorough, even your explanation in the beginning, the presentation, and then the demo. As we had some questions in the middle, we might have answered everything by now. I don't know, maybe, is there any questions from the attendees after seeing the demo? Maybe something that triggered your mind during the demo that you want to ask? Taswald, yes, please.
Yes.
Yeah, sorry, Stefan. I was actually waiting for other people to give others a chance. Yeah, so you can tell that I've been playing around with this for quite a while.
Yes.
Yeah, and I'm a beginner at SPH, so forgive me if some of the questions that I ask are simple questions. What I noticed is when I'm restarting a simulation, so what I'd normally do is I'd normally fill up my DEM particles. So how I thought I'm going to do the simulation is I'll fill up my DEM particles, and then I'd load my SPH particles thereafter. So I created inlets and did that in that order. The problem is, let's say now I want to change the SPH mass for another simulation. So I at the point where my DEM particles are loaded, I save that for restart. What I notice is when I try to go back to alter with the SPH, even the mass of the SPH particles, let's say the particle size of the SPH elements, I can't do that. It's grayed out. What would you recommend?
Yeah, currently there is a limitation on the SPH. It's not quite as flexible yet as the DEM particles in terms of restart and modifying your simulation. So I don't have a good answer for you at this stage.
No, I understand that. So it
Yeah.
means that it's a general problem. It's not just me.
It is a limitation,
Yeah.
yes.
I thought I was doing something silly. Okay, and then my last one is the volumetric fill. So I've played around with, I need to fill the interstices between my DEM particles with fluid. And when I read up about the volumetric fill, I thought that that's the simple way of doing it. Just specify a mass of particles, and the seed will grow, and automatically the SPH elements will be filled inside. Now, what I noticed is that it's a very linear relationship. So as the SPH particles grow, as the DEM particles grow, the SPH particles grow proportionally. Now, I have the problem where maybe, with the difference in densities, rocks are 3 times as dense as water. So I would have expected that when I look at the actual filling level at the end, I'd see more rocks or the equivalent amount of rocks as water, just the water filling the interstices. But what I noticed is because it grows linearly, once the SPH particles hit the boundary wall, because they're growing at a very fast rate, then it stops filling. And that's your quote unquote fill. So I just wanted to know, am I doing something silly with the volumetric filling? Is there some toggle or something that I should try in order to get just the interstices between my particles filled?
I think you must show me what you're doing. Maybe
Okay.
well, I think we must maybe organize a meeting and we can have a look at it. Yes.
Yeah, no. Sorry to put you on the spot, but
No problem.
Yeah.
I've played around with the volume fill as well a little bit, but not necessarily the combination of the SPH and the DEM as a volume fill.
Okay.
So SPH on its own, what I've seen so far works fine, but yeah, maybe if you have a combination, there might be, again, maybe some limitations at this stage, but we can have a look at that.
Yeah, so what I ended up doing was I ended up creating 2 different inlets and filling a mass of SPH particles with a mass of water on top of it. But now the problem is you take time to mix the water. It takes extra simulation seconds to mix the water and get a reasonably well mixed bed. So yeah.
Yeah, I understand this.
Okay, and the last one, I'm done after this. I'm done. When I'm running the simulation, sorry, Lara.
No, it's fine. Please ask your
But
question.
maybe my problems will be others' problems also in the chat.
Yes.
What I notice is when I'm running the simulation, on the simulation log, it says that the SPH elements are clipped at the maximum allowable density value.
Yes.
Is that a physical limitation? So let's say if you want slurry that's above that, you might as well just put that value in.
It's a limit. It's limiting it so the particles doesn't get too heavy. So it is based on the size on the density you specified. As far as I know. Let me just see if I have if it's shown here. No, it's not. I didn't solve it now. It limits it so that it doesn't become too dense or too not dense enough. Based on the interaction of the particles. I think it's just to keep the simulation stable as far as I know. But I don't have a clear answer for you at this stage.
Okay, and importantly for me as a user, does that slow the simulation down, the fact that it's giving me that it has to clip the values and stuff? Meaning, am I better off just putting that number in?
No, not as far as I know.
Okay.
But I think it's just limiting the value specifically when it needs to use it at that stage. So I don't think it slows down the simulation. That's what I've seen anyway, because I've had it in some of my simulations as well.
Okay, all right.
Yeah.
Okay, I'll keep quiet now forever and ever. Thanks so much. I really appreciate it. Really. Thanks. Sorry, Lara.
No, it's fine.
No, I must say thanks to you. Thanks for your questions. I'm sure there's participants who definitely did get value out of your questions and the answers. There is a question from Yaku. So Yaku, you may ask your question.
Hi, Stefan. Hi, Laura. Thanks for the presentation. Just a quick question. Can you run with 2 different SPH fluids at once? So can you have a fluid with 2 different properties like a syrup and a water or air and water, or is it only one fluid at one time?
At this stage, it's only one fluid. So you can't have a mixture of different SPH materials at this stage. It's a single SPH. It is something
Please
they
put
will
it as a
work on.
request.
Yeah, it's. I think, as far as I know, they're already working on that.
Okay.
But I'm not sure when it will be released.
Okay, and then the next one is, will the fluid, have an effect on the walls, like they call it now, in terms of predicting wear? So let's say you've got a fluid with a lot of fine particles in there, which is like abrasive. So if it flows around a bend, removing the particles from that and just looking at a fluid, will it predict some sort of a wear, accelerated wear, like you would do with normal particles, or does it not capture that information?
It does solve for the forces. Sorry, that's the one thing I didn't show actually now in my thing, which I forgot to show. But for example, I can get, remember when I switch on the interactions, I can get SPH forces, for example, the nodal Y forces on the solid. Let me just hide the
So like it used to be shear power or whatever you would have called that.
Yes, so
in
it's
the
still
past.
a bit limited, but you can get the information to some extent out of this. Let me just switch off some of these things and put the transparency. But you can see, for example, here, this is the nodal Y force, the vertical force of the SPH particles on the walls. So you can
Okay. Yeah, that's good. Thanks.
get some of the forces already out, but as I say, it's a little bit limited still. But maybe it's something you can have a look at and see if that can give you what you require.
All right. Thanks, Stefan.
Okay, any other further questions? If there's no further questions, what we will do, as Stefan said, we'll set up a separate session with Taswald, and then if there's any other attendees who'd like to have a separate session dedicated to them, just email us and we'll book a slot for you. Then we can cover your specific requirements at a later stage. Okay, so then what I will do, I'll stop the recording.